So we're going to start this by first graphing your sine function. Okay, let's graph your sine function. I don't think I can fit both of these on the same page, can I? Maybe if I shrink it down. Almost. Okay, you have this down here too, right? All right, so we're going to graph your basic sine function. And this is how you're always going to start. 0, 1, 0, -1, 0. And just bring it out to the other side. So and remember, it's a continuous function. Okay. Now, does this curve pass a vertical line test? Yes, it's a function. Does it pass a horizontal line test? No. So its inverse can't possibly be a function. We want to make this reflection over the line y equals x. We want to swap all these pieces. But before we do that, just like the parabola, we have to restrict the domain. What quadrant do we always start rotating around the circle? Quadrant 1. So the first thing we're going to do is go to quadrant 1. Here's my quadrants. There's my quadrants. So the first thing I'm going to do is go to quadrant 1 until I fail a horizontal line test. So I'm traveling along. Whoops. As soon as I hit this spot, don't I cross over and fail a horizontal line test? So I stop right there. But I notice I can come backwards a little bit, can't I? I come backwards down here. Whoops. I stop right here. This is the restricted domain for sine. Sine can only go from -π/2, which is my -π/2. I'm writing it out like this first, just so that you see it. From -π/2 to π/2. And the reason I wrote it like this is because here's your number lines from here to here. I cross through -π/2, -π/4, 0, π/4. I go from here to here on my number line. Those are the only parts I can use. So if this is quadrant 1 in my unit circle, what quadrant is this guy back down here? Quadrant 4, right? Because isn't this a continuous cycle? So I go 1, 2, 3, 4, 1, 2, 3, 4. Don't I keep going 1, 2, 3, 4? So if I go backwards off my unit circle, aren't I in quadrant 4? Right? So the sine is restricted to quadrants 1 and quadrants 4. Now, looking at your graph, quadrant 1, is that a positive sign or a negative sign? Positive, it's above the x-axis. Quadrant 4, is that a negative sign or a positive sign? Negative. So I notice in my restricted domain that I get one positive quadrant and one negative quadrant. In my regular sine curve, I get 2 positive quadrants, 2 negative quadrants, right? But I fail a horizontal line test if I come over that crest. So I have to cut it right there. Now, I'm going to pull up my calculator just in case you don't have a calculator handy. If I take the sine of 30, hopefully I'm in degrees. No. If I take the sine of 30, it's positive. Agree? I hit clear. I get a positive answer. If I take the sine, and I'm going back here, of -30, I got to go backwards, I get a negative. Right? So far, so good. If I say, give me an angle whose sine is 0.5, I have 2 quadrants, 1 and 2, who have a sine of 0.5, right? But when I do this, that -1, like Amanda said, that -1 that she remembers, this is an inverse. So this inverse is only going to give me one angle. Because in my restricted domain, there's only one angle that has a positive sign. Your calculator always gives you a true inverse. Remember when we did your inverses and we draw inverse on there? It gives you the true inverse. So now, if I say second sine, negative 0.5, what angle do you think I should get? Negative 30. There's my negative 30. Yet, I know sine is negative here and here in quadrants 3 and 4 down here. I know sine is negative down here. And if I come all the way around, isn't that the sine of 330? But I don't get the sine of 330. I get the sine of negative 30. Because in my domain, it goes from negative 90 to positive 90. So it has to be in there, on that number line. Agree? Okay. It's a little different. This is why I didn't want to do this while you guys were graphing 4 quadrants and 8 quadrants and everything else. So our domain for sine is going to be negative pi over 2 to positive pi over 2. Did our range change for the restricted sign? This is restricted domain. Did our range change? We still went from negative 1 to positive 1. Okay. Now, when we do an inverse, when we take its inverse, don't we switch the domain and the range? So the new domain will become what my range was. And the new range will become what my domain was. Now again, here we go back to radians and numbers here. 3.14 divided by 2 is 1.57, I think it's 1.57. So again, you're going to have to convert to numbers because here's the problem. Usually your angles are here, your numbers are here. When we take the inverse, look where this came out to. This is going from negative 1.57 to positive 1.57. So look where my range went. See my range going above the 1, below the 1? This is an inverse graph. This is if I took this little squiggle line, which I'm incapable of doing, and making a reflection over the y equals x. So it's going to look like this. So do you see where my domain goes? My domain stopped a little short of pi over 2, didn't it? Look at your graph on your paper. Do you see it? If you could pull that little line down, doesn't it stop short of pi over 2? Because pi over 2 is 1.57. My domain now goes from negative 1 to positive 1. So isn't it approximately about the 1 to negative 1? So this is where your radians and your numbers fit together. I couldn't show you this before because I didn't want to confuse you with inverses just yet. And this is the only time we talk about restricted domains and we talk about inverses. So this is where your sine negative 1 comes from. This is where your arc sine comes from. Arc sine and sine negative 1 are the same thing. Arc sine says, give me an arc whose sine is 0.5. Remember you do your measurements in numbers on your arc sines, on your arcs, with your SOAR. Did you do SOAR? No. Okay, so sometimes you know how you measure your central angle with the degrees? Well, we can measure it in radians, we can measure it in numbers, we could make it linear. That's what a radian does. It says the radius is equal to 1 arc for that angle. So you're saying, give me an arc or give me an angle whose sine is negative 0.5, positive 0.5. I'm looking for the angle who would cover that arc on that circle. So that's why they use arc. So it's interchangeable. Sine negative 1, arc sine. That's how you're going to see these written. So it's going to say this. Sine negative 1, 0.5. And you're going to say 30. Or it's going to say arc sine 0.5, and you're going to say 30 degrees, or pi over 6, for looking in radians. Okay. So that's how you're going to know that this is an inverse. So when you go to do these, you're going to make your little sine curve, you're going to cut it off, and this is what you're going to determine. I am in quadrant 1, I am in quadrant 4. So right away, you're just going to do this. God bless you. 1 is positive, 4 is negative. You're only going to get 2 angles. One a positive one, one a negative one. And your calculator kind of confirms it. So even though we give exact values and we find angles that way, and I need to see where your triangles go, you can cheat a little bit. If you put it in your calculator, you can figure out what quadrant you're supposed to be in, right? Okay, so this is important that we reverse these, but the most things that you want to make sure you do is this right here, because this is going to tell you what quadrants am I in. Okay? Questions? So far, so good? Okay. I'm going to jump down to the tangent. I'm going to pass the cosine right now. I'm going to come down to the tangent. Oh, this is working out nice now. Okay. Now, tangent says, I have a natural asymptote. Where are your asymptotes for tangent? Well, who's your domain for tangent? Real numbers, except where n is an odd integer. And your range was what? All real numbers, because that's like the little piece of spaghetti that goes on and on. So here's my asymptotes. And, oh, I missed the n. Sorry, I'm sorry. I said it, but I didn't write it. Okay, so here's your tangent curve. And then the next one. And then on the negative side as well. So now, I'm going to start in quadrant 1. I'm going to follow my, let's call this a curve. I'm going to follow my tangent curve until I crest, right? Until I come over a hump, because then I fail a horizontal line test. So if I'm in quadrant 1, will I ever come over the line? So that's good for me, right? And I come backwards and back here, and this is still good for me, right? So this is just like the sign. 1 and 4. Okay? So the only problem here is the restricted domain for tangent says you can go from negative pi over 2 to pi over 2, but you cannot use pi over 2, right? Isn't that what my asymptote is? So again, in my number line, this would be open, this would be open. Here's my 0, this is good for me to use. Here's my pi over 4 negative, here's my pi over 4 regular. I'm using all these angles. So I'm technically going from quadrant 1 to quadrant 4. Quadrant 1 and quadrant 4. I will never be able to use these guys because this is where my asymptote is. I can't take the tangent of 90, and I can't take the tangent of negative 90. The tangent of negative 90 is the same as the tangent of what positive number? 270. Good. You guys got it. So I write my domain as parentheses, negative pi over 2 to positive pi over 2. And my range is all real numbers. So now when I switch these for my inverse, here's my inverse down here. My domain becomes my range. My range becomes my domain. And all it's doing now is, if you remember that pi over 2 is like 1.5, aren't I pretty much going here like along the 1.5 line? Where I make my asymptote here now. My asymptotes are going to go from being vertical, it's just going to go like this. Oops, now it's going to be horizontal, and that little squiggle line is going to go this way. It's going to go like this. If this keeps on going, it doesn't stop. Because your domain now is all real numbers. It's your range that's cut off. But that's not the part that you need to concentrate. When I say tangent, negative 1 of, I don't know what, radical 3. Let's do negative radical 3. If I'm looking for an angle whose restricted domain falls in, I need the inverse of this, and I need this to be negative, what quadrant will I be in, first of all? 4. I can only be in 1 or 4. Can't be 1 because it's positive in 1, negative in here. So I build this like this. This is my y over x. I say, oh, what angle is this? reference angle? 60. And 60 in radians is what? 60 goes into 180 how many times? Pi over 3, because I need radians. So how do I name that angle? I name it pi over 3, but what quadrant am I in? 4, and in 4 aren't my angles in the negative direction? So I say negative pi over 3. Right? Just like we did with your sine. Your sine and your tangent almost look the same. They're 1 and 4. They kind of fall smack in the middle of that 0. They are equal just like around the 0. But the only problem is a tangent can't use 90 or negative 90. I'm not going to ask you to draw these inverses just so that you kind of understand this. And this will kind of help you relate your radians to regular numbers. Here's my pi over 2, 1.5. Okay. Everybody good with this? All right, we have one more to do with the cosine. I did this tangent because it looks very much like the sine. So it's not so scary, right? No. It's worse than it looks. How come I don't have a graph of the cosine on here? You have this. Okay, that's the little piece of cosine. That's the little piece of cosine. Okay, so we can work with this. This just, let's extend this. I'm sorry. Extend this. So your cosine curve, oops, get rid of that. That's wrong. I told you I can't draw. This is pi over 2. This is your cosine curve. You recognize it, right? They only drew this little piece because you only need that little piece. And then it goes here. Don't forget it goes like this, right? And it keeps on going. So this would be where 2 pi is. Comfortable with that? This is your cosine curve. They only give you a little chunk because that's the little chunk we're going to restrict. But I want you to see the whole cosine curve. So again, we're going to start in quadrant 1. And I'm going to move forward. If I move forward and backwards, I go over that hump, right? So I have to cut it right here. And I'm going to move forward until I go over another hump. So I come down here. I'm good so far. Oops, I got to stop. So from here to here is your cosine curve. What quadrants is this? What quadrant is this guy right here? 1 and 2. Oh, that makes good sense to me because cosine x is positive over here and negative over here. So from 0 to 180, I hit a positive quadrant, I hit a negative quadrant. And look, I can't go backwards because I fail a horizontal line test. So cosine works a little differently than sine and tangent. It uses quadrant 1 and quadrant 2. So therefore, I'm like this. I can use all of these angles in here. I use the 0, I use the pi over 4, I use the pi over 2, I use all of these angles up to pi. From 0 to 180 I can use, because I get half of them positive, half of them negative. And that's my goal. So again, if I said in my calculator, and this is why when you have a reference angle in quadrant 2, let's say this is a 60-degree reference angle, right? And you want this angle, this cosine, you look this guy up and you say, what is like the cosine, whatever this is. So this is the cosine would be 1 over 2 of this angle. So if I say this is negative, when I look this up and I say second cosine negative 0.5, I'm going to get that angle, 120. Where if I did the sine for that quadrant, I would never get it. So that's giving me my negative, and my second cosine, 0.5, is giving me my positive. So I'm in quadrant 1 positive, quadrant 2 negative. Only 2 quadrants for each one. Okay, so it makes sense so far? So your domain now is going to look like this. 0 to pi. And your range is still the same as before. -1 to +1. I like to do this like this so that you can kind of see the number line of all the angles that it hits, but we still use these. So remember, when I take the inverse, my domain is going to become my range. And my range is going to become my domain. And if you think about pi, it's about 3, right? So it's a little over 3. So if you see it going up, well, they actually labeled it pi instead of 3. They labeled it by the radian number. So what you're going to remember is cosine uses 1 and 2. Basically, to sum this lesson, cosine is going to use 1 and 2. 1 is positive, 2 is negative. Sine and tangent are going to use 1 and 4. 1 is positive, 4 is negative. But the tricky part is you have to give me the negative numbers in a negative angle. You can't come all the way back around that circle. You can only go on that curve. So when you start these, you look at your sine curve and you say, okay, I'm going here, here. So I know -90 to +90. That's only where my answer can be. I can't say 300, I can't say 330. I have to say -30, -60. Make sense? Okay, so let's try a couple. All that to get to these. So you did some of these last year, maybe?
No, we did that.
You didn't do any. They probably didn't do inverses with you. Inverses is a little tiny aspect of trig that is important, but is off the beaten track. So they probably, when they were trying to get you to do all your trig, if they throw this at you, then it's hard because when we go do equations next, you're back to 4 quadrants again. In fact, we're more than 4 quadrants. So when we restrict them and then we come back to 4 quadrants, everybody's like, wait a second, I thought we did 2. But inverses work totally by themselves. So our first thing here says arc cosine. So I don't know where to start, so I kind of sketch my cosine curve. My cosine curve goes like this. I say, okay, cut it here, come down, cut it here. So I am in 0 to pi. This is how I would start this. And I would say quadrant 1 is positive, quadrant 2 is negative. It's going to be here or here. So of 1 and 2, which one is the positive one? Then wake up, you need this. So I'm in quadrant 1. So I label. And does anybody recognize this as a special right triangle? What's the angle? 45 degrees. And can I cheat? I can cheat. I can do second cosine, radical 2 over 2, and find my little angle in quadrant 1, but I want to see this labeled. So your angle is pi over 4. You have to return me an angle. Because the special right triangles are 1, radical 2, and when they rationalized it, it became radical 2 over 2. If you didn't know that, you could say x over r, so you can do this. X is radical 2, r is 2, so I'm missing a side. I still don't see my angle, right? So I do 2 squared is equal to radical 2 squared plus y squared. So I get 4 is equal to 2 plus y squared, subtract 2. I take the square root, I say, oh, this is radical 2. Now I say, Lily, my 2 legs are the same. What's my angle? I have an isosceles right triangle. That means this angle and this angle has to be the same, and they add up to 90. So this guy's a 45. That's perfectly fine too. If you can recognize that 1 over radical 2 is rationalized to radical 2 over 2, sometimes it just helps to unrationalize it. But that is fine. So my angle, this is what this says. Find me an angle, and I'm going to just say restricted, whose cosine is, that's why I know I need to find an angle. Our cosine says, find me an angle whose cosine is. They could write it like this too. This says the same exact thing. Just remember, it's restricted. So if I really am off on this and I kind of cheat a little bit, I say, oh, because you always have access to a calculator. So if I say second cosine, and I say radical 2 over 2, if I can get all this in, it's going to come back and it's going to say, you made a mistake. Oh, I put the parentheses there. Sometimes this guy makes me do a parentheses and sometimes it doesn't. Okay, so I'll get that. Now if my thing was negative, if it said negative pi over 2, negative radical 2 over 2, what would my answer be? Negative 45, negative pi over 4. So let me see if that is true. I'm going to put a negative sign here. Not true. Because what quadrants are we in? So what does that tell you? So can you cheat?
That's still negative.
No. Cosine is different than tangent and sine. Cosine is 1 and 2. Tangent and sine are 1 and 4. So if I don't know where it is, I cheat a little bit. Where does that, what quadrant does that land in? Second. Didn't we draw 1 and 2? Didn't you tell me before 1 and 2? So how could I be in 4? Well, before when we drew this, didn't you tell me cosine is restricted to 1 and 2? Yet you told me quadrant 4, but when we checked, we're not in quadrant 4. So can you cheat a little bit on your calculator? You can cheat a little bit. It'll kind of lead me to this.
I meant that like 135.
Because you still have a 45-degree reference angle. These triangles have to be identical, don't they? All that's changing is where my SIG ends are. Like this is a negative, that's all that's changing. This is a reflection. Cosine is in 1 and 2. But if I forget, I put it in my calculator, it tells me. I cheat a little bit. Okay, because you're only getting one angle for a negative, one angle for a positive. Okay. Sound good? All right. Let's have you guys try this one. Yeah. That's what this says. If you see what I wrote before, arc sine says, I want an angle whose sine is. That's how we translate this. Originally, they used to say an angle is the same as an arc, because don't we make these as central angles? Don't we make these as central angles when we drop our triangles off your unit circle, off any circle? Aren't they central angles? And isn't the arc always the same as the angle and the central angle? So we can take this and change that word to arc. An arc whose sine is, and out of all this, they came up with arc sine. Makes sense, right? But it kind of goes back to your geometry a little bit. Your central angle is the same as your arc. And your radians is an arc measurement. Do you guys know what a radian means? So 1 radian measure for an angle says this. Oh, that's cool. If my radius is 5, okay, and I take the string and I go 5 this way and measure this, the same, this angle is 1 radian. Where my arc measures the same as my radius. You did SOAR, right? Remember doing this? So if I solve for my angle, I'm just going to divide by R. I think you did SOAR.
We did that in physics.
You did it in physics?
Yeah.
And so there's your angle. It's 1 radian. That's where all this comes from too, because it's measuring in radians actually. But this is where this saying comes from. But also you could see this saying in sine -1. That's asking me the same thing. Because in your calculator, when you put in the sign, don't you say, give me an angle? I'll give you the sign, give me an angle. So what's the answer to this guy? Good. -pi/4. Because first thing, I don't know where to start, right? So I start, I make my sine curve. I don't know where to start. Always start like this if you don't know where to start. So follow this along. Look, cut it. Oh, go back down, cut it. What quadrants am I in? 1 and 4. I start like this. Where is sine positive? 1. Where is it negative? So I don't want the top one, I just want the bottom one. So then I label y over r. So radical 2 over 2. So again,
For that, why did you like y over r? Like, that's the y over what radius? What's the r stand for?
radius or hypotenuse of my circle.
So could you just put it where like the signs are, like opposite over?
Yeah, you could if you wanted to, but try to use the x and the y and the r on the circle. It's so much easier.
Oh, I remember it easier.
Okay, whatever works, or however you like to remember it. So again, I could do Pythagorean theorem and find out, oh yeah, this is a 45. But watch, I can't go all the way around like this, can I? No, I can only do this from here to here. Isn't that where my number line went? From -90 to +90. So I have to give this as a -45 degrees or -pi/4. So each one of these has only 2 quadrants. So when you start inverses, my advice is draw your 3 pieces, restrict your domain. Don't swap them, just restrict them. And find out what quadrants you need to work in. Okay.